Recall in demonstration 1 how the car started off with a velocity of 0, and by the end of the scenario it had a velocity that was not 0. Additionally, it was moving away from our 0, away from our sensor in the positive direction, so our graph is going to be up here. And if we know that it started out at rest and that it ended at not rest, then our graph should look something like that for velocity versus time. Now, as far as acceleration goes, remember when we're drawing an acceleration versus time graph, what we're looking at is the slope of our velocity versus time graph. Now, in this case, our velocity versus time graph has a positive slope. So because of that, we should have a positive acceleration. And it should be constant, because this slope is constant. Now, in terms of applied force and net force, we really need to think about the scenario forces as a whole. So what I'm going to do is I'm going to take, and I'm just going to kind of cover this up for a minute, and I'm going to draw a small picture of what my setup was. It looks something like this. And then there was a string, and it was pulling it. So I have a force pulling the string that way. I have that. And I know that my car ended up moving in that direction. So then when I take and I draw my free body diagram for this, and I think about the agents that are acting on this cart, well, I know that the earth is providing a force on the cart, so I would say the force from the earth on the cart. In addition to that, I know that the track is providing a force on the cart. The force from the track on the cart, holding it up, keeping it from falling through the track. I know that. So then I know I have a force from the string on the cart in that direction, string on the cart, pulling it, making it go that way. Now, I said in the demonstration introduction that we were going to ignore any forces that oppose the motion of our cart. So then there's our free body diagram. So if we're looking at how this cart's moving, really our net force on this cart is given by this applied force, which is the force of the string on the cart. So in this case, we're going to say that those forces are the same. So then I know that if I'm accelerating, I'm going to have some force. My applied force isn't changing. The string is always pulling with the same amount. So then I get something that looks like that. And since I know my applied force and my net force are the same, then I draw the exact same graph. So really what we're looking at is we're combining kinematics and then taking into account looking at why it moved that way by looking at the forces on the object.